Alright, I'm going to talk about factoring, which is the reverse of expanding an expression. So expanding an expression would be something we could do with this expression here. Because we have, in parentheses, an entire expression, we can't simplify it anymore because they're unlike terms, a constant and a variable term. So what we can do though is distribute this 2 to each term. And if we do that, this is expanding. We would have 2 times the first term plus 2 times the second term. Our first term will be 2x in blue, and our second term is 1 in red. So if we continue this process, we have 2 groups of 2x to make 4x, and 2 groups of 1 to make positive 2. Alright, that was expanding. So now if we're going to do that in reverse, which is what factoring is, we're going to start by kind of moving back to this step. And the reason that that works, 2 times the first term plus 2 times the second, the reason this works is because 2 is a common factor of both of these terms. 2 times something could be 4x, and 2 times something could be 2. And that something, I think as we can see, because we're reversing this process, in this case will be 2x, and in this case 2 times what would be 2? That would have to be 1. So now we're one step away. Notice the reverse process here. So as you can maybe predict, our last step is going to be having these two 2's, because they are both being multiplied by these terms. We're going to sort of consolidate here, which means these 2's can be written out here as 1, and instead of 2 multiplied by each element separately, we're going to do 2 multiplied by both elements together, 2x and positive 1 here. So now we're back to where we started. We have factored this expression. We factored out a 2, and that 2 is here, and now we have 2x plus 1. So I hope this helps you see how factoring is the reverse of expanding. They undo each other. And maybe we can try now another example, but we'll just start with the factoring. So let's say we want to factor 6x plus 4. So we want to find a common factor that we could take out of both of these numbers. In this case, a common factor would be 2. So 2 times the first term plus 2 times the second term. Okay, now here's the question. 2 times what would be 6x? This would be 2 times 3x. 2 groups of 3x would be 6x. And 2 times what would be 4? That would have to be 2. 2 times 2 is 4. So now we're one step away. Now we have 2 times each of these separately. So what we can do is write 2 times both of them together, which would look like 2 times 3x. And because it's a positive 2, it's plus 2. And so now we have factored this expression. And it's good to know you can always check to make sure your factoring is correct by going in reverse and expanding this expression. So if we did 2 times 3x, that would be 6x. And if we did 2 times 2, we would have positive 4. So that is back to where we started. So that's how we know this is our factored expression for 6x plus 4. So now I want to try with some slightly more complicated examples. Let's see. If we had the expression negative 8x plus 2. Let's try this one. So a common factor here is actually also going to be 2. These are both even numbers, so if they're even, 2 is going to work. So now we have 2 times each of the elements. But because of this negative, we have to be careful. 2 times what would be negative 8x? So that would have to be, because 2 is positive, to get the answer to be negative, we would have to multiply by negative 4x. 2 groups of negative 4x would be negative 8x. On this side, we think 2 times what would be 2? Well, that would still just be 1. So now if we move our 2 out to here, because each of these are being multiplied by the same number, by 2, we can consolidate by saying 2 times each of these elements together. Negative 4x and plus 1. Okay, now we have factored it. We can always double check by saying, is 2 times negative 4x negative 8x? It is. And is 2 times 1, 2? It is. So there we go. And we can look at another one where, let's see, if we had negative 12x minus, let's see, let's try 18. Okay, so we want to find a common factor for 12 and 18. And we want it to be the greatest common factor if possible. That will always help us out, otherwise we'll have to factor more than once. So the greatest common factor, I know they're both even, it could be 2, but let's see, could it be higher than that? 3 could go into 12 and into 18. So let's see, 4 could go into 12, but the best one I think is going to be 6. 6 times 2 is 12 and 6 times 3 is 18. So if we factor out a 6, what would each of these have to be? 6 times what would be negative 12x? That would have to be negative 2x. So 6 times negative 2x should be negative 12x. And you can kind of think how it's just 6 times negative 2 is negative 12, and there's an x attached. Over here, 6 times what would be negative 18? That would have to be negative 3 to make sure the answer is negative. Now we can write it all in one set of parentheses. 6 times negative 2x. And here, it's plus negative 3, which is really just going to be negative 3. Adding a negative is just negative 3. And there we go. We can double check to make sure 6 times negative 2x is negative 12x, and 6 times negative 3 is negative 18. So we are all good, and that is our answer. Alright, I hope this was helpful. So remember, you can always double check once you get your factored form to make sure it gets you back where you started. And you always want to be asking the question, if you take out a number, this number times what would get you here? That's how you can fill in the blanks along the way.